Hello, and welcome to How a Data Analytics Company Developed a Platform to Cut Down Complex Data Challenges. My name is Chris Skriniak. I'm a Partner Solutions Architect and the Global Machine Learning Segment Lead for the Amazon Partner Network, and I will be your host and moderator for today's presentation. When you joined today's webinar, you selected to join either by phone call or your computer audio. If for any reason you would like to change your audio selection, you can do so by accessing the audio pane in the control panel. From this control panel, you will also have the opportunity to submit questions to today's presenters by typing your questions into the questions panel. We will collect the questions and address as many as we can during the Q&A session at the end of today's presentation. Also, at the end of today's event is a brief survey. Please stay connected until the end of the broadcast and submit your feedback as your opinions count. Lastly, the PowerPoint presentation will be available through SlideShare, along with a recording of the webinar on YouTube via an email that will be sent 2 to 3 days after the conclusion of this event. So keep an eye out for the follow-up email sent to the address you provided. Again, welcome to today's live webinar, How a Data Analytics Company Developed a Platform to Cut Down Complex Data Challenges. My name is Chris Skriniak, the AI Machine Learning Architect for Amazon Web Services and Machine Learning Segment Lead. I will be your host and moderator for today's webinar. So here we go, there we go. Our agenda for the day is we're going to take a brief look at Amazon Web Services, artificial intelligence, and machine learning offerings. Then we will move to Stephen Hillian, Senior Director and Data Scientist for Tibco. That will be followed by a presentation by Ravi Hubley, President of Explore Digits. So let's begin. Oh, and then of course our Q&A session. So machine learning on AWS is essentially the centerpiece for digital transformation at almost every company globally at this point. I joke sometimes that no matter how much money a company is spending on IT this year, almost anything they're going to talk about at the end of the year is what they've done in machine learning. It's obviously a very important process, not only for distinguishing characteristics of your company, but importantly, improving customer experience by taking business operations to the next level, reducing costs, adding new capabilities. As prediction is the nature of almost every decision-making process, machine learning is becoming a part of almost every strategic discussion. Clearly, it's a place for innovation and competitive advantage of the marketplace, in the marketplace. Our mission at AWS is to put machine learning into the hands of every developer. With our decades of experience in machine learning at Amazon Retail and developing these services within AWS, we've developed the broadest and deepest set of machine learning services available, with more than 200 new features and services launched at AWS in the last year alone. We hope that you've had a chance to take a look at products like SageMaker, our breakthrough IDE that has given people the ability to take a concept in machine learning, label data, train data very inexpensively, and put machine learning inference into production both in the cloud and on IoT and mobile devices in a comprehensive manner. So when we talk about machine learning at AWS, I mean, literally there aren't enough pixels on the screen to represent the number of customers that are using these facilities at AWS. And importantly, TensorFlow is the leading framework at the moment. With we also have strong support for MXNet and PyTorch, but more than 85% of TensorFlow projects are occurring on AWS. So with that said, I would like to hand over the presentation to Stephen Hillian, Senior Director and Data Scientist at Tibco.
Before I get talking about Tibco's data science platform, and how it sort of sits within the AWS environment. Let me spend a few minutes just talking a little bit more abstractly about what I, well, at least personally view as a sort of an ideal data science platform. Like what I would put together if I was starting a team of data scientists from scratch and had a choice of whatever technologies. This is sort of roughly what I'd expect the thing to look like. Of course, I need access to data. And these days, that means more than just, say, traditional databases and data marts. I want really to have access even to raw transactional stores, account information, account transactions, web logs, and so on. I want access to streaming data, so not just static data sitting in those relational databases, but also streaming data. And of course, not just relational data stores, but also NoSQL stores, Hadoop and Spark, and so on. And easy access to external sources of data and APIs. Now, I still need a place to land that, even if I'm doing largely real-time analytics. I still, for most model training and model building, I want to be doing that on historical static data for the most part. And so I need a place to land that data, ideally a sort of centralized analytics sandbox. And in my experience, while Hadoop and Spark and MPP platforms can be really useful for that, I would really ideally like a combination of stores for unstructured data as well as relational data, more structured data. So some combination of, say, Hadoop or Spark and a relational database as sort of the central repository for where my data scientists are actually going to do their work. The next thing I want is some development environments where the analytics can be developed specifically. And these days, while open source is clearly critical, and I want to have access to completely open frameworks and say specifically Python and R for different styles of development and different preferences on my data science team. My experience is that if I want to grow a team quickly and not be constrained by the technical backgrounds of my data scientists, I want really a broad array of development metaphors that I can use for different styles of users. So you have the coders using Python, for example, and the so-called citizen data scientists using maybe sort of more point and click, drag and drop type interfaces. I need easy access to data, as I've already said. And so those, and of course, I need to be able to do the machine learning and modeling itself. So all of those metaphors must be capable of doing both data prep and feature generation and model training and building. And then, of course, a really important aspect is actually operationalizing these data science workflows and capabilities. It doesn't matter if I've built the most accurate and parsimonious and self-explanatory model. If I can't put that into operation, what's the point, right? So I need to be able to turn those workflows, regardless of whether they were built in visual frameworks or in code, into scoring and live applications, both batch time and real-time scoring, and then applications that are web-based as well as pushing out to the edge through devices. So easy operationalization, eventually then feeding into a whole variety of different applications like you see on the right there. So that's sort of my ideal state. Now, as you expect, we've built all of this. Well, we've actually done, I think, a pretty good job. The Tibco platform is pretty broad. I want to start at a super high level and say that in summary, we have built a platform that allows you to construct complex machine learning pipelines in both visual and code-oriented metaphors. We've built a visualization and data exploration platform that allows you then to surface your findings and your insights and your models through traditional reports and dashboards, and then eventually out to live applications and through streaming data. And then we've done all of that by integrating with the most common sources of data, both cloud and on-premise, and actually leveraging those as computational frameworks. So Hadoop and Spark and Hive and traditional relational databases. And our particular focus today is on our sort of flagship deployment where you have both the data science platform and the visualization and the application running in the cloud against sources of data like Amazon EMR and Amazon Redshift, going against data sitting in data stores like S3. So that's sort of the high-level bird's eye view of the platform that we've created. Now, just to drill into that a little bit, and then when Ravi goes through his use cases, he'll really bring this to life and talk about how this was used in a real-world situation. But just to drill into those components, as I mentioned, we've got this sort of dual metaphor, sort of hybrid environment for doing data science, both a visual drag and drop environment that you see on the bottom left there, as well as code notebooks for SQL, for Python, for R, and so on, covering between them all of the classic algorithms, all of the tools that the data scientist would expect to find in her toolbox. The way we've built this is in a framework that is collaborative and scalable and easily deployed. So all of the components that I've just talked about, visualization, the data exploration, the dashboards, the reports, data prep, data access, model building, model deployment, those are all available on the web, in the cloud, in a team-oriented environment, almost like a Slack-style environment where it's very easy to share your data and your outputs and your results and your models and your workflows and your notebooks with the rest of the team. So highly connected and collaborative with all the metadata stored centrally, so that for easy governance and for searching and finding. So that collaborative aspect is at the core of the way that we've built the platform. Secondly, we've done this in such a way that it's inherently scalable. So whether you're coding through PySpark in notebooks, or whether you're using our visual drag and drop environment, all of those operations from data prep through the machine learning can be deployed down into the cluster or into the database. So whether you're doing simple aggregations and joins in Redshift, all the way out to complex machine learning and deep learning in Amazon through EMR or through SageMaker, all of that can be easily parallelized, essentially without very much input, sometimes none at all, from the user. It just happens. It just gets scaled automatically to run in parallel. Even down to the level that if you're deploying Spark jobs, for example, or if we decide on your behalf that a Spark job would be the greatest way to run this random forest or to run this join, then we'll take care of deploying that as a Spark job for you from the visual environment, for example, and we'll even tune automatically the executors and the memory and so on down in the Spark cluster. And then finally, you know, as I've obviously indicated at this point, all of this can be deployed in the cloud. In particular, we don't just run in the cloud, but we actually take advantage of the components in the cloud that Amazon offers. I've already mentioned EMR and Redshift, briefly mentioned SageMaker. So we're not just running in the cloud, but we are connected within the cloud, within AWS, to take full advantage of everything that Amazon offers in terms of data access and machine learning. That's all available now on the AWS marketplace, and I think we're the only vendor that's actually earned the competency certification in both data services and platform solutions. So check that out on the AWS marketplace. Finally, I just want to give a brief overview of the architecture there. You've got the Tibco data science platform sitting at the center, connecting to Amazon EMR and Redshift and S3. And then on either side of that, we have our data virtualization component that can federate queries across these different data sources. And then on the right-hand side, the ability to deploy these both through streaming, through APIs, through containers, and out through SageMaker, and through edge devices using our open source framework, Flogo. And our live applications for embedding data science applications within rapidly built, rapidly developed applications also sits within AWS. Before I switch over to Ravi, I'd like to give my own example project that we've been working on using all of this infrastructure running within AWS. Our work with the tipping point community. It's actually, like Ravi's, it's another example where we've used the platform within government projects, ultimately sort of for the benefit of citizens. And in this case, we worked on a project last year with Tipping Point. Our work with them continues to look at the way that parking citations were distributed in the city of San Francisco. And for better or worse, there are many parking citations distributed in the city. I can speak from bitter experience. And for many of us, these are things that we don't tend to think an awful lot about. But for many of the citizens of San Francisco, these represent a considerable financial burden. And we wanted to analyze that and see if there were unfair biases in the way that tickets were distributed. And we found that, in fact, there were. We've given presentations on this, which I can reference elsewhere, so I won't go into this in too much detail. But as a result of this work, citation fees were streamlined and reorganized with payment plans made available to lower income individuals. So many citation fees were eliminated and the whole process made a lot more fair. But the real point here is that Tipping Point started out this project with a large quantity of data that the government had given them and which they've gotten through sort of sunshine provisions within city law. They had a nascent data science team, and so they were struggling. The data was too big, they didn't know where to put it, they didn't have the tools to work on this, and they were largely working with in-memory applications, Excel and MATLAB and so on. So they came to us and said, how can we work with larger data, and how can we make this easy for our, again, so-called citizen data scientists? And that's where our framework came in. And we actually worked with them collaboratively, my own data science team, working with the data science team at Tipping Point and with the San Francisco Department of Financial Justice. We were able to collaborate easily. All our work was done in the cloud. It was easy for us to then show that and demonstrate it and work through it in detail with the San Francisco city government. And so it was a very open and transparent project, and it was easy for us to, so to speak, show our work and prove that the statistics that we had generated were real and were based on the data that the city had given us. Okay, Ravi, I'd like to hand over to you now so you can talk us through another example in greater depth.
Thanks, Stephen. That's a great introduction to what I'm going to be presenting here. The name of my presentation, I've named it as Analytics Modernization, and there is a reason behind that, because the focus of my presentation is about enterprises that already have analytics solutions, and that they have been doing analytics for a long time. But the new wave of machine learning and artificial intelligence is pushing them into leveraging those platforms for their benefits. So it's not just about leveraging the new capabilities, but also migrating or modernizing their existing analytics solutions to the new set of tools and get benefit from that. The reason behind they want to do it is because they have invested quite a bit of money and effort in building traditional analytics solutions. We'll go in detail about those kind of investments that they have done and how they can go around modernizing this into the new enablement platforms available through cloud and solutions such as Tibco. Before I go, let me describe my company. We are a very we focus on data engineering and data science solutions, focused on large enterprise modernization. We have been working with the Tibco data science product and AWS for more than 5 years. A team of skilled resources have been doing that and worked on multiple problem domains, leveraging this particular platform. And hence, we will talk more specifically about Tibco data science and how we have leveraged that through along with AWS. So traditionally, and enterprises have been doing analytics, and it has been in existence for a long time. People have been doing for understanding how they have been performing, like normally called as descriptive and diagnostic analytics. So analytics such as how many customers do we have, or how much customer churn has been there, to identifying clusters of customers based on patterns. This existed, data warehouse technologies along with various analytics solutions existed and in the enterprises, and they continue to be used. The push in machine learning and artificial intelligence is It's not just about what happened. It is now to think about what could happen, which is called as predictive analytics, and machine learning plays a significant role in there. And then go beyond that in letting machines or technology suggest us, like call as prescriptive analytics of if that happens, what are my options and what could we do? So, so that's I know the artificial intelligence is a very overused term. The whole sci-fi kind of story about how AI exists or AI is implemented is far from practical right now. Obviously, it's maturing, but it's far away from there. The practical AI, we call it as practical AI, is more about prescribing what could be done. And there's some use cases around it which can help us understand, like a space agency we worked with is one of the things they do is like predicting whether is this an astronaut talking or is there noise. They have to do that. They have to give attention to an astronaut more than the noise and able to detect from all the voice, it's an astronaut, and then give attention is important. It could be more than like artificial intelligence could be not just detecting or predicting it's an astronaut, is this astronaut in stress? The context in which he's working is understanding that and coming up with options of what could be done, recommendations to address his stress or get the right people to address the issue is kind of we call it as practical AI. So that's how these use cases are. There's some more use cases out here, but in general, it is about predicting to prescribing and bringing in more context is what AI is about. So a use case that will take drill down more further is about a nationwide enterprise that focuses on improving the quality of care, quality of healthcare across the nation. Its focus is to make the quality of care delivery more effective and a more affordable cost. The goals is to make the caregiving safer. It is to promote better communication, apply various preventive treatments, and enable best practices. And to do all those and make obviously all of those affordable too. So the foundational principles for making those goals, to achieve those goals, they need to innovate, they need to make data-driven decisions, and they need to share those insights of what they have learned uh, across all the organizations and strengthen the whole infrastructure and sharing the knowledge and disparities in healthcare across the nation. So those are kind of foundational principles, and data-driven decision making is critical for them. So some of the activities they have to do, like to achieve those goals, are like root cause analysis of what is a challenge and understand the cause behind that challenge and try to come up with the right policies associated to address that cause. In addition, they have to come up with measurement strategies of how do we measure healthcare, whether a particular care is better than something else. Measuring healthcare of how one feels is a very difficult game. So coming up with the right strategies that everybody can agree on and using that to measure whether the quality of care, how it is one of the things they have to do so they can observe what's happening in terms of caregiving. To achieve those measurements and to do the root cause analysis, everything has to be data driven. Collecting that data from various sources in various formats and structures, huge voluminous data, and being able to aggregate them and analyze them is a important activity. Uh, Having done the collection of these diverse set, able to then apply appropriate analytics, whether it's machine learning, whether it is general visualization, and or it's just general monitoring, it needs various kinds of solutions to do that. And all has to be done more and more transparently that everybody agrees to how measurement is happening and how these policies are impacting. So these are kind of activities this particular organization has to do. To go more specific, I will take an example scenario. Uh, it's about hospital readmissions. One of the biggest challenge or cost challenge is a person goes to a hospital, gets treated, but because of some issues, he comes back. The cost of care in a hospital is very expensive, and having a person or a patient come back to a hospital causes significant cost impact and also quality of care impact. So, so one of this use cases is around how can we address or reduce hospital readmissions. For doing that, one has to identify what are the hotspots, where is that these hospital readmissions are happening. Understand that it may not be just the hospital. Hospital may have done the good job, but once you are out, the patient is out of the hospital setting, he may go to a skilled nursing facility or some home health, or he may not follow the right procedures that has been recommended, and that causes a patient to come back. So to understand the dependencies, not just what's happening in a hospital, but in a network, means data is not about just the hospital, but also about the ecosystem. And able to gather that data from the ecosystem and do root cause analysis is a pretty, and then use that to contact the healthcare providers to convey the cause, and then address the cause of the issue, and then monitor whether those have addressed the issues, is all an example of the scenario that we are talking about here. So to do that, as I said about modernization, these solutions exist. The platform, the solutions exist, but they, like an example of the environment they have is a Unix-based environment in which they have centralized system where all the data is kept uh, to whatever is possible. I mean, no, this is not a scale-out architecture, it's a scale-up architecture. So the data is difficult to have more and more data in it and all diverse set of data in it. So, but that's the environment they have, and they have analytics tools like SAS to analyze this. It's traditional client-server technologies. The challenges with these legacy environments of this, some of the observations is because of the limitations, the analytics teams spend 80 to 90% just finding the data that is relevant, and as well as preparing the data so that they can visualize or analyze. And it's very limited. Statistical and analytics is also done, but limited to what is feasible. So there's a lot of challenges with these traditional environments. In addition to the environment, the data itself has a lot of issues of what is being presented. The data, there's significant delay in getting the data from where the data is created to the time the data becomes available for analytics. So they use traditional solutions like mainframes and traditional client-server based analytics solutions like SAS. The data moves in various batch way formats and extraction and storage. This whole solution is very expensive. It creates a lot of data quality issues. It also creates a trust issue with what the data is finally into the hands of the analyst and the outcomes. And if you cannot trust the outcomes, it's very difficult to make decisions and convince changes to happen. So some of the drawbacks which we try to address with the new solutions are like the need for large compute and storage, the need to catalog all this diverse set of data so people can discover the data and understand the data that exists, need data more closer to real time so that one can monitor and one can be much more trustworthy to the data, and need more effective analytics, and analytics that is enables you to do machine learning, enables to you apply AI techniques, as well as does not impede you in bringing multiple data sources together to enhance the quality of analytics. So two sets of solutions we built around AWS and Tibco Data Science. One addressed the data challenge, and one addressed the analytics challenge. The solution that addressed the data challenge, called as EDOS, Enterprise Data Operating System, enables you to manage the data and get the data more closer to real time and make the data useful. Whereas analytics platform is bringing in the right kind of analytic tools, whether it is machine learning specific compute platform, where you could use GPU based processing, or you have just visualization on large set of data where you need a lot of memory intensive nodes to be instantiated and get a more effective visualization. Uh, those kind of two solutions we built around AWS and Tibco. We'll talk more about them as we go forward. So let me talk about EDOS. The main goal of this data operating system was to provide users access to this diverse set of data. And data comes in many forms, whether it's relational data, it is unstructured data, it is log data, it is XML, it is EDI transactions, able to capture all that data and closer to real time and bring it into a storage platform from where analytics can be done. And in fact, also identify duplicate data and reduce the duplication of the data so that that becomes very significant, less effort from the analytics perspective, that you are not working with duplicate data, identifying linkages between the data, identifying what data types and what data really means, like auto tagging. All those techniques are being done as the data comes in, and then enable those this data to be analyzed by the tool of choice. People have we present Tibco data science, but people have affinity towards many other tools, and being able to use those tools also on this data so that we could separate out, decouple storage of data from compute is what we did. The benefits were like we had flexibility because of the decoupling, and also there was the way we architected, there's no single point of failure, and multiple tenants could run on this platform without impeding each other. At a high level, this is how we called it as a federated data lake on AWS. The key concept is leveraging AWS data lake formation capability. We create this enterprise cluster where we ingest all the disparate data, whether it's relational or non-relational data. Sometimes de-identify the data also because of sensitivity of the data upfront. We provide cataloging service to catalog the data that's coming in and do some kind of preparation like enhancement, enrichment, formatting of the data, and create these data. Do this processing at large scale on an EMR kind of service or a Lambda based service, and put the data into a usable storage buckets like AWS S3. AWS S3 happens to be our data lake. We then catalog the data using the AWS Glue data catalog and enable that data to be available for multiple tenants. This whole thing is secured, and we make it role-based access control through using AWS IAM capability. In parallel to that are all the various tenants, and each tenant, which is represented as programs here, can have, and for us, they have their own clusters. They have their own optimized compute platform as appropriate for their needs. So as you see, a program number one is using its own Hadoop cluster using EMR, but has its own S3 buckets and it has its own catalog called Apache Hive, based on Apache Hive, where Tibco runs on top of it. And they do all the machine learning analytics and some of the ETL activities related to that in that particular cluster. We have in another program which is not doing advanced analytics, but are basically just doing data visualization and reporting. And they have their own optimized clusters for supporting that. And this enables us, as all of these are built using cloud formation scripts, we are able to instantiate new tenants at a much shorter time and and tweak their environment as appropriate to their needs, and have an elastic environment as they grow and as they shrink, as the needs arises. Some more details around this architecture, in much more detail of what specific technologies we have been using. Like, for example, we use the Presto SQL engine on top of the EMR engine to enable SQL-based access to the data. And we use, as I mentioned, the central data catalog is created using data catalog capability. And this exposed central catalog is made available to a particular tenant, which is using a Tibco data science product, which runs on its own cluster. And they may have their own data, and they may bring their own data to that environment in addition to the enterprise data. The advantage of this modernized architecture, which became the foundation for migrating as well as running new analytics, is eliminated the need to replicate data, and also reduce the various data centers they had before, and eliminated many of the data movements, like extraction of the data from the source and moving it. Now, data is not extracted. Data resides where once and being used multiple times, which improves the data quality too. So some of these were the program needs which were met. Is the critical factor is performance independence, as each tenant had its own compute cluster. They could enhance their cluster or reduce their cluster or tune their cluster as appropriate to their needs. It became very easy for us to price each tenant of how effective, how much they are consuming, and make them pay what they use. It became easy to scale up and scale down to every tenant. More importantly, it helped us to resolve issues like the operation maintenance teams were able to localize any issues that happen in any job run or any analytics performance issues, and know which particular cluster is having issue or which particular program is having, and became easy to isolate the problem and manage it as well as resolve it. Each tenant had the single point of failure was eliminated, and improved the security posture. Now every one of the tenant did not any secure data what was relevant for them was only in their environment and not exposed to all the other tenants. It also enabled our customer to govern the technology and get the best value out of products that they have, rather than have these diverse set of tools. Because of the limitations of the previous legacy environments, there were diverse set of tools used, and this enables us to more consolidate and get the best value of these tools. The results of this is around, first is the data became more, instead of taking weeks to get into the hands of analysts, it is now feasible to get them in minutes. The analytics at scale means we could perform processing, that batch processing which used to take hours and days could be done in minutes. The solution like Tibco enabled us to collaborate, make data science, not only data scientists, but the data preparation and data management people collaborate and understand the meaning of the data and describe the data as they used, enabled ad hoc analytics to be feasible, and then enabled users to bring their own data. So that enabled the foundation for data, the foundation for analytics. As I mentioned, we decoupled the analytics platform from the data platform. The analytics platform, the vision was to enable a productive data science. The biggest challenge in data science is the skills that is needed to do data science. Data scientists are expensive. They need to know a lot of things, not just programming language, but also the domain. Ability to reduce the entry barrier for a person, any analyst to become a data scientist was one of the major vision around this analytics platform, and enable these folks to apply various new techniques, more open source solutions for analytics also being available to them, so new techniques could be applied more quickly on this data, and able to do these analytics at scale and not at samples. So able to analyze this at a full scale of data means more improvement and more accuracy in the analytics results. And that's what we did, is we brought the Tibco platform and the AWS platform together to create what we called as enterprise analytics platform. The core capabilities we had to provide with the platform included obviously the storage and the processing platform, which came with EDOS. We presented an event-based framework leveraging AWS Lambda. We provided data governance, currently using a COTS tool, but more and more going towards AWS Glue Data Catalog. Do predictive transformation using Tibco Data Science drag and drop capability to do ETL. No coding approach towards doing data preparation. Able to use visualization at scale at the full data set, and then apply advanced analytics capabilities like AI and machine learning, using no coding as well as code-based approach that Stephen mentioned about from Tibco, also integrated with AWS SageMaker and capabilities, enabled this EAP platform to meet the goals as mentioned before. The platform, the whole solution looked in this way as, this picture, let me go from the bottom left, looks at all the data sources, structured, unstructured data, use data ingestion technologies available in AWS like AWS DMS or Glue ETL or even Tibco's ingestion framework, and bring it into S3 bucket, catalog it, the data stewards describe and manage this catalog, and make this available for Tibco Data Science, Tibco Data Science, for a data scientist to leverage this data and build and investigate analytics. Once the models were created, which Stephen showed, these models are deployed as AI bots, exposed as REST APIs, simply on a Java engine. Before it gets deployed, we make sure there is a AI governance play in which, and we strongly recommend that, where one looks at these predictive models and looks for any bias in the models, ethical bias or any other bias that, or even accuracy of these models in presenting the appropriate insights. And these AI bots are then, these REST APIs are called through various applications where the humans, business users use it to get insights and predictions. This is continuously monitored by the AI governance board to see whether these AI bots are performing the way they need to be performing. And various visualization tools like Tibco Spotfire can help you detect any outliers in these predictions. We also continuously gather the feedback from business users. We call it as data exhaust, based on also how they interact with the applications and the predictions, to use that as a feedback to continuously improve the models that are being built by the data scientists. So data scientists not only get the data, but they also get to know the user behavior with the insights, whether there were any false positives, false negatives with the insights, and use that to retune the model. And that's how this continuously evolves and makes it more and more accurate. Some of the best practices we would suggest for anyone going this path is, these are some of the foundation things you need to have. You need to have an event-based, API-based approach so that you could decouple your AI bots or AI predictions or machine learning algorithms from the applications. Using an API-based approach will enable you to decouple that. And having an event-based framework to initiate that is one of the best practices. Otherwise, your code, your application code can get very complex. You need to build this as a big data approach. That means the data that is being used to build the models has to handle variety, velocity, volume. The traditional relational database only way of approach doing things will not meet the goals of a large enterprise. We have to separate the compute from the storage. EDOS and EAP are an example of how you can manage the data using EDOS so that multiple analytics techniques can be applied, and you can shape the data the way you want for a particular analytics techniques. Through EAP is how you would separate out compute from storage. The ability to do effective analytics is the shape of data in which you can get the data so that you can apply the analytics. Hence, ability to separate out storage from compute is critical for that goal. Very important to have quality issues addressed. A single source of data for AI services is very critical. If you have two different AI services running on two different data sets and they are giving different predictions, the trust in AI or machine learning techniques is critical. And if you lose the trust, it's very difficult to get back the business users to use your solution. Cloud hosting makes it very easy, and using DevOps CI/CD techniques for deploying new models and even new data into the data lakes, the cloud makes it very useful. The AWS data lake formation is a good solution for one to use. Leveraging open source, baked it into a proprietary solutions that exist in machine learning libraries can be very cost innovative as well as not a good long-term story. Able to bring in open source machine libraries like Tibco data science has done is it brings in, exposes many open source libraries as well as enables you to integrate them if anything new comes in by yourself, so you could leverage it as soon as they become available, is the way to go rather than having a proprietary platform supported by a single vendor. Using a licensing model which is subscription-based licensing rather than an upfront fee and then a maintenance fee is a very big problem. Having an annual usage-based software licensing would enable you to not get tied into a platform. Enable democratizing data science by reducing the entry barrier by using solutions like drag and drop applications of new algorithms rather than a coding based approach where you need specialized skills, difficult to define skills. I think we strongly recommend using more no coding approach or low coding approach towards data science so that you could enable business users and even business analysts who are not deep data scientists to start looking and evaluating and be part of the whole implementation roadmap. We strongly support going with standards, but it has been a very difficult because many tool vendors are struggling to make this happen. But PMML and PFA standards by which you could expose your models so that those models can be run in any other tool vendor engine like scoring engines is a recommended approach. Tibco data science does support PFA, and that's the reason we like this tool. I would strongly recommend you looking at tools such as that that support these standards. Here's one more just to give a final outcome. Here's one of the customers of ours, the Lewin Group, who have been using our EAP platform. Lewin Group is in the health policy research, analytics, and consulting. They are the ones who do this healthcare quality data measurement and also support various government agencies in coming up with write quality measures and monitor them and measure them. They have been using EAP platform, and these are some of the results they presented. One of the major benefits they saw was the knowledge transfer, like able to do in a no-code approach, enable the developer or the data scientist to convey how the model is built or analytics is built with the end users. So it became the trust in that analytics was much increased. They were able to collaborate between themselves and maintain the code that was generated to do analytics. It encouraged the domain knowledge, to use the domain knowledge and also the skills of model development to come together more collaboratively. And finally, to reduce the number of logic and the storage to make also infrastructure savings significantly. That's all I had to present. I hope this was useful. I will transfer this over to Chris.
Thank you, Ravi. Excellent. Wow, you covered a lot of ground there. So thank you very much. It is now time to answer questions. So as you see in the control panel for our webinar session here, you can answer some questions here. And we have a few minutes. We went just a little bit long, but we do have a few minutes here to answer questions. If you don't mind, I'll start. Well, first of all, you covered so much ground. It's almost so much ground. It's almost hard to say where to begin. But one of the concerns that often comes up when I'm working with customers is relational data, in particular, is still majority on-prem. But the horsepower is in the cloud. Stephen and Ravi, I'd sort of love to hear from both of you how you balance and enable those capabilities of using the data that may still be on-prem, but getting the power that's in the cloud.
This is Ravi. Let me take that. This is part of our analytics modernization activity, right? You have customers' data in the relational database on-prem, and they want to benefit from the cloud. One of the things we have seen is able to get onto the path of using cloud, using a hybrid cloud, so that you have access to the relational database even in the cloud. So that is like an infrastructure level connectivity issues from the tools that do analytics in the cloud to be able to reach out to the relational world. That's one, so that you don't have to migrate all the data upfront to the cloud, or only then you can do the cloud services. You can have the connectivity and then apply access to that data just like it would look like it's in the cloud, though it's on-prem. That's one of the ways that people have been able to overcome the data being in the cloud and data being on-prem. The other part is obviously you can use migrate the databases also from relational database into the cloud-based relational databases. And that's where we have used services like AWS DMS, data migration service, to migrate the relational database to whether it's Redshift or even other DMS, RDBMS services that are available. Those are two other ways. There are other ways is just separating out data in relational and big data platforms like AWS EMR and S3. The structure and the format of data in S3 is different than the relational database. So you can use services like AWS DMS or many other ETL techniques to migrate data from your local RDBMSs for the data that is needed for analytics onto the cloud into the AWS S3 data lake. So a case-by-case basis, you may want to decide how you want to go, but you need to create a roadmap of what is your end vision of where you want to be. It could be a hybrid path, or it could be a migration path, or it could be an integrated path.
Fantastic. Yeah, that is a big challenge for a lot of folks, and we certainly do have a few things at AWS that help enable that. Here, questions are coming in now from our guests. I'm just going to read this verbatim. I have a question. How do you manage change resistance from a very data jealous IT department when handling migration towards a cloud platform? What are the challenges to tackle, and what's the best way to convey this solution to them? I sort of love the opinionated take on this, but that's sort of some ground truth perspective there.
I think the business is driving, finally drives the change, and IT is an enabler. So executive commitment is one way to make the change happen. The other is empowering the IT teams with proper skills to work in the cloud so they feel part of the change rather than an impediment is another way of we have seen getting over the hub. So education, training, executive commitment are some of the ways I would suggest one to look at and migrating from or getting support from IT teams, local data center IT teams.
Yeah, and I think if you don't mind, just add to that, the experiences that I've had with enterprises globally is that once you take a lot of the pressure and responsibilities off of especially data ops from on-prem to cloud managed, not only do they experience reduced costs because they don't have to handle a lot of the infrastructure issues that were required, especially if you're using a database system like Aurora, say, on AWS. But what happens is that they've got a lot more freedom to work creatively with the data scientists and get more involved in highly valuable projects and products. So it really accelerates the creativity of the team in general, which is really needed. I mean, data is transforming so much these days. It's the top of the hour. If we can just squeeze one last question in. You mentioned data de-identification. I wonder, and that's such a critical issue right now. Can you define that just a little bit and maybe just share a little bit of experience that you've had with a de-identified data lake and some of those challenges?
Yeah, I think data de-identification is, first of all, the data that I'm talking about here is a very sensitive data, healthcare data. Able to share data is also, as you know, is very critical so that we could make a lot more analytics possible. But not having the sensitive data and constraints around it and not able to share is a big challenge. So data de-identification plays a significant role. And to do that, there are some interesting solutions, tools out there that can de-identify the data at scale and can be done at the time of data ingest itself and be cataloged as a subset of data available for users who cannot have sensitive data, who cannot work with sensitive data. So there are very good solutions out in the market. We used a solution called Data Guys, which did the job for us. There are many custom ways to do it too, but the most important lessons learned is having this sensitive data not be able to de-identify the data such that the analytic strength still exists in the data. So many times you de-identify the data and it becomes not usable. It is only meant for them, like building a website or something just to see if it works. But able to de-identify data such that you can also do analytics with it means you have links of data across multiple data sets, and hence enterprise tools such as Data Guys can help you do that. I would say that's just a approach we took, and and make sure you have data that is usable for analytics and not de-identified that it cannot be used.
Well, thank you very much, Ravi, and thank you very much, Stephen. It's a great session, and I want to thank all for attending today's webinar. Please remember to stay connected and complete the brief survey at the conclusion of this webinar. We look forward to supporting you in current and future projects. So thank you again to all, and have a great day.